The tower leans at an angle of about 84.7 degrees. The figure shows that 198 feet from the base of the tower, the angle of elevation to the top is 45.4. And all of that information is given to you in your picture. So you don't have to worry about drawing your picture. Find the distance to the nearest foot from the base to the top of the tower. So we're figuring out this distance right here. Well, do I have enough information for me to use the law of sines? Remember, to use the law of sines, I need an angle side pair. Well, I don't have that yet, right? I know that I'm going to be using this 45-degree angle with side B because that's what I'm trying to find. I don't have side A. I've got angle A, but I don't have side A. I have side C. What I would like to be able to do is take side C and angle C and make that ratio. The only thing I have to do is to figure out angle C. I know two of the angles of a triangle. So to figure out that third angle, I'm just going to do 180 minus 84.7 minus 45.4. And that's going to give me 49.9 degrees, if I got that right. So now I have an angle side pair with my C's that I've highlighted in yellow. So I set up my ratio with my C's and my B's. So let me give you all a minute to set that up and solve that. Now you should get approximately 184 feet. Okay, problem 2, we're finding H to the nearest 10. My first step here, step 1, is to find all the missing angle measures that I can. Okay, and you're going to do that based on the fact that angles of a triangle add up to be 180, or like these two angles down here form a straight line. So I know this angle is 180 minus 74. So this is 106. I've got this triangle here, this oblique triangle, with its obtuse angle. I would take 180 minus 106 minus 48 to figure out this angle in here. This angle is going to be 26 degrees. I have a right triangle here. These angles are complementary. So I could do 90 minus 74 to figure out this angle. So that's 16 degrees. And I can also say that this big triangle here, this big angle, 16 plus 26, so that big angle is 42 degrees. So I have every angle labeled in my picture. I might not need them all, but everything is there and labeled, and it's going to help me be sure that I've got everything right. Because you can always go back and try and check your work by being sure your biggest side is opposite your biggest angle, your smallest side is opposite your smallest angle. What am I asked to find? Find H. Okay. I want to find H. So I know that H is somehow going to relate to this angle opposite that is 74 degrees. So I need to find this side that I'm going to highlight in yellow. Well, I have enough information in that obtuse triangle that I can set up a proportion, because I know an angle, I know all three angles, and I know an angle side pair, so I can use the law of sines here. So I have, let me call this side A, right? Because it's opposite of angle A. So I'm going to have A over sine of 48 degrees equals to 212 over the sine of 26 degrees. Solve that for A. You get approximately 359.39. So side A is 359. Let me zoom out here so you can see my picture and my work at the same time. Side A is 359. I now know the hypotenuse of that right triangle. Sine of 74 is opposite over hypotenuse. So the sine, what I'm going to do, I'm going to do this. The whole right triangle in yellow there. So, so I can label this from my yellow triangle, just so y'all can kind of keep up with your notes. I know that the sine of 74 degrees is opposite over hypotenuse, so h over 359. So in order to solve that, I multiply 359 times the sine of 74, and I get that height to be approximately 345.5. Problem 4 says to use the given measurements to solve the triangle and round lengths of sides to the nearest tenth and angle measures to the nearest degree. So I'm not given much in this problem at all, really. I've got A to be 300 and B is 200. And I do not know an angle measure, but I do know that angle A is twice angle B. So I'm going to go ahead and set up a proportion using law of sines with angle A and angle B. So I have 200 over sine theta equals 300 over sine 2 theta. That's all that you can do with that problem to begin with. So write it down, and even if it doesn't look like it's going to work right away, then go ahead and write it down and see what you can do. I've got both of these signs in terms of theta. I just need to somehow get rid of that 2 theta. Well, if you look at your reference sheet, there is what's called a double angle formula. This is one of those things that was in chapter 3 that we sort of skipped over, but I don't think it's that confusing to go back and look at this and say, okay, in place of sine 2 theta, I can replace this, right? So I've got 200 over sine theta equals 300 over 2 sine theta cosine theta. So this is really the one of the things that you should have gotten out of section 3.2 that we had skipped, is just to know to substitute this in place of 2 theta to help simplify an expression or an equation. Now from here, there's a couple of different things that I can do. Bless you. I can work on getting my variables out of the denominator. But what I'm going to do is take this step by step. I'm going to multiply both sides of my equation by just sine theta. So multiply this side times sine theta, this side times sine theta, and my sine thetas all cancel out. Now, you probably could have just canceled the sine thetas out if you wanted to. So over here on the left-hand side, you're going to have 200. And on the right-hand side, you have 300 divided by 2 cosine theta. I'm going to go ahead and simplify this. So I have 200 equals 150 over cosine theta. Now, once you get here, you have to know how to solve for cosine theta. And I think that's one of the things that some of y'all struggle with, is knowing how to get your variable out of the denominator. What I'm going to do is multiply both sides of my equation by cosine theta. So over here on the right-hand side, they cancel. I'm running out of room. Go to the paper here and write down what I have. I've got 200 cosine theta equals 150. What I would do from here is divide both sides of my equation by 200. So I have cosine theta equals 150 over 200. Now, if you wanted to simplify that, you can. I'm just going to leave it as 150 over 200 so you can just keep seeing where I'm going with this. I need to solve for theta. So I want theta to be cosine inverse of 150 over 200. And remember that when we're doing these problems, we are in degree mode. So you could just stick this into the calculator. So let me give you all a second to put that into the calculator and see what you get for your answer. All right, here you should have approximately 41.41. Now, in my math lab, they would probably ask you to round that to the nearest degree, maybe the nearest tenth. But right now, I'm going to keep it like this because I don't want to round too early in my problem. If I do, my other numbers that I need to find are going to be off a little bit. So this theta is, let me see what I'm going to do. Put this in my calculator so we can look at this together. Theta is 41.41. So I could come back over here to my picture, say this is 41.41. What was this? Cosine inverse of 150 divided by 200. What I would do is go ahead and multiply that times 2 to give me this angle measure here. So it would be 82.82. Now, your final answer in my math lab, you would want to round that up to 83. So I think this is a good example of where rounding too early would hurt you. If you took this and rounded it to the nearest degree, you would have 41. If you doubled that, you would have 40 or 82, right? 41, double it, 82. But actually, this gets rounded to 83, right? Because we are going to double it before we round our final answer. Okay, so this is the numbers these are the numbers that I'm going to need to use to figure out angle C. Remember, angles of a triangle I have to add up to be 180. So C would be 180 minus 41.41 minus 82.82. So angle C would be approximately 55.77. Again, I don't want to round yet until I get to my final answer. I need to use this unrounded number here when I set up my proportion to figure out side C. Right? So this is angle C of 55.77. So I have side C over the sine of 55.77 degrees equals I'm going to use this angle here because this was the one that was found first, right, before I did any rounding. So I would say this is 200 over the sine of 41.41 degrees. Now, when you're solving that proportion, cross multiply and divide. That means you're going to multiply the two numbers that are diagonal. So 200 times sine 55 divided by your third number. Right? Multiply these two, divide by sine 41, and you get this side to be approximately 250.